Now, finally we get to learn the chapter 12, lesson 1. The first lesson is called angles on a line. They are angles like this. Look, AB is a straight line and D is a shared vertex of two angles, angle ADC and angle BDC. So these two angles, they share the vertex and the two sides of them make a straight line. They are called angles on a line. One important property of angles on a line is the measure of this angle and the measure of this angle make 180 degrees. So this is how we can write it. Measure of angle ADC add measure of angle BDC is 180 degrees. Why is that? Well, we know that on a straight line, we can draw one and only one perpendicular line to it. And this perpendicular line makes two right angles. One right angle is 90 degrees and two right angles is 180 degrees. So, the sum of the measures of these two angles will make 180 degrees. Well, do you think it only applies to two angles? Or it also applies to three or more angles? The concept of angles on the line. Yes, of course. When you have more angles, let's draw it a straight line like this. Even when you have more angles, if they share a point, the vertex, and their two sides of their sides make a straight line, they are still called angles on a line because the sum of all of them still makes 180 degrees. Just like this one. Okay, I'm going to go ahead and show you the sentence. The sum of angles measures on a line. Well, the sum of angle measures on a line is 180 degrees. And just like this one, these three angles are called angles on a line. In some cases, there are more than one straight lines. Like in this figure, AB is a line, CD is a line. How many sets of angles on a line do you think you can find? Okay, let's look at line AB. Very obvious that BCD are three angles on line AB. So we can write angle B, angle C, and angle D. The first set of line angles on a line we can find. And let's look at angle C and D. Very clearly, ABC are angles that are on line CD. So, angle A, angle B, angle C. So these three angles. Are there just two sets of angles on a line we can find? If you think so, you are as smart as Miss Fan is. Because in the beginning I thought there were only two sets. Then I realized there are more sets. On line AB, there's angle BCD. And on the other side, there's another set of angle AFE. They're also angles that are on line AB and they make 180 degrees too. So, the third set is angle A, angle F, angle E. The same thing for line CD. So we already found angle ABC, angle FED are also angles on line CD. So angle F, angle E, angle T. Right. So if there are two lines, well, at least in this case, for the two lines, we found 4 sets of angles on the line. This is a quite, this figure has many lines. In the questions on the book and the workbook, you don't always have this many lines. So it may not be as confusing. But yeah, this is just an example, so that the questions, yeah, if it is a difficult, like more confusing example, it will make the other questions easier for you. But in any case, I believe you're pretty well familiar, you understand pretty well the concept of angles on a line. The property of angles on a line is very useful. We can use it to solve many problems. So like for this one, these 3 angles are, they make 180 degrees. If we know this angle is 50 degrees and this angle is 100 degrees, what is this angle? Well, we know that measure of angle POR plus measure of angle ROS plus measure of angle SOQ is 180 degrees, which is 50 plus 100 degrees. I kept writing degrees like this. Plus measure of angle QOS is 180. So the measure of angle QOS would be 30 degrees. As we have said, the property of angles on a line is very useful. You can use it to solve many problems. Like in this figure, OR is a line, QM is perpendicular to the line, so it forms 2 right angles. And this angle OMP is 30 degrees. Can you find the measure of angle B and angle C? Well, so our goal is to find measure of angle B and measure of angle C. It's not too difficult to realize that, right? If this is a right angle and part of it is 30 degrees, measure of angle B would be 90 degrees minus 30 degrees, which is 60 degrees. All right. Now, measure of angle C. Now we can pretty easy, it's pretty clear to us that it's 90 degrees because it is just the other right angle that the perpendicular lines form. And another way to find the measure of C, angle C, is measure of angle C is, we know that angle C and angle B and the 30 degree angle form 180 degree. So angle C would be 180 degrees minus 30 degrees and minus angle B, which is 90 degrees. And you get the same answer, 90 degrees. All right. Now, let's use the properties of angles and solve this problem. In this problem, OR is a line, MQ is perpendicular to the line, and the angle PMO is 30 degrees. Find the measure of B and C, angle B and angle C. If we think of the properties of the angles, we know that the right angle is 90 degrees and part of the right angle is 30 degrees, and we would find out angle B is 60 degrees. So measure of angle B is 90 minus 30, which is 60 degrees. And one method to find out angle C is to use the property that we have just learned. The sum of angle C and angle B and 30-degree angle is 180 degrees because these three are angles on a line. So angle C would be 180 degrees minus 30 degrees minus 60 degrees, and it is 90 degrees. Or if we there's a easier way too. If we know that this is a right angle and it's 90 degrees, we would know that the other angle is a right angle too, because a perpendicular line to another line, it forms two right angles, and naturally C would be 90 degrees.